How do we know that triangle ABC and triangle ADE are similar? In order to discuss this, I'm going to draw each triangle out separately. So here is the smaller of the two triangles, and this is the larger one. We need to label the vertices. So this is the triangle ABC, and this the triangle ADE. First consider this angle. It has to be the same as this angle. That's because if we look at the original diagram, it's actually the same angle. So we can say that angle CAB is equal to angle EAD, and the reason we give is common. In other words, this same angle is in both triangles. If we now make use of the parallel lines, we can see that we can form an F shape. That being the case, this angle and this angle must be the same. That's this angle here and this angle here. I can say that angle ACB is equal to angle AED, and the reason I would give is that they are corresponding angles. Finally, since we know the three angles of a triangle must add to 180, if two of the angles are the same, the third must also be the same. So we can say that angle CBA is equal to angle EDA, and we could give the reason that there are 180 degrees in a triangle. Note that the way the angles are marked tells us which angles are equal. This one and this one. The two double marked angles are equal, and the two triple marked angles are also equal. This also enables us to say which sides correspond to which. AE goes between single marked and double marked, and that's the same as AC. Not the same length, but they correspond to each other. They're in the same position in each of the triangles. The same is true for ED and CB. In this case, they go between the double marked angle and the triple marked angle. And the same is also true of AB and AD. In this case, they go between the single marked angle and the triple marked angle. We want to find the length of BC. The overall length, AD, is 22 centimeters. AB is 11 centimeters, and the two sides correspond, telling us the scale factor of the enlargement when we take ABC up to triangle ADE is 2. So the lengths in triangle ADE are twice the lengths in triangle ABC. We know that these two sides correspond. We've already discussed this. BC is in the smaller triangle. It follows that BC is 1/2 of the length of DE, which is 6 centimeters. We now want to find the length EC. As a first step, we can find the length EA. We know that this will correspond to the length AC. We've already discussed this. EA is in the large triangle, so its length is going to be 2 times the length of AC, which is 2 times 8, which is 16 centimeters. So the whole of AE is 16 centimeters. We want EC. That's going to be AE, which is 16. Take away the length of AC, which is 8. So we have 16. Take away 8, which is 8 centimeters.